A very good morning to all my dear students. Welcome back to your science class. We are back here again for revision. Today we are going to revise two chapters which are motion and time and electric current and its effects. Let's start our revision. So, what is motion? Motion is the action or process of moving or being moved. Or we can say that motion is the phenomena in which object changes its position over time. We already know that any change in position with time is called motion, but what really matters here is that whether an object is showing slow or fast motion. Moving object shows three kinds of motion: linear or straight, circular, and curvilinear. Linear motion in which the object travels in a straight line, circular in which the object travels along a circular path, and curvilinear in which the object moves along a curve. But how do we know whether the motion is slow or fast? This we decide by seeing the speed with which the object moves. Now, what is speed? Speed is distance covered by an object in a fixed interval of time. Types of speed: uniform speed, non-uniform speed, and average speed. Uniform speed: when the object travels a fixed distance in same time gaps, it is said to have a uniform speed. Non-uniform speed: when an object covers different distances in different time gaps, it is said to have non-uniform speed. And average speed is the total distance traveled by an object divided by the total time taken by the object is called its average speed. Example of uniform speed and non-uniform speed are ticking of a clock. The clock ticks with the same speed always. The distance covered and the time remains same every time. But if we take example of a car, the car can change its speed. Sometimes it can run slower and sometimes it can run faster. It means that it shows non-uniform speed. The formula to find speed is equal to total distance covered upon time taken. What if we have the speed and time but we want to find the distance? Then the formula will change and it will become distance is equal to speed and time. Similarly, if we need to find time when distance and speed is given, then it will become time is equal to distance upon speed. Now comes our next topic, that is measuring time. Time waits for none, right? But how do you know that? A ticking watch measures the change in time, but have you ever thought how it was measured before the invention of the watch? The answer to these questions seem complex for us, but for our elders, these were easy to calculate. Shadows played an eminent role in acknowledging the time of day when the regular lunar moments signify the change in the month. As we all know that moon has different phases which change every day. A month, according to our elders, started with a full moon and ended with a full moon. Likewise, the completion of one revolution by Earth around the Sun signified the completion of a year. Our ancestors solely depended on these repetitive events that helped them measure the time accurately. There are many events in nature that repeat after a time interval, such as morning. In the morning, the rising of the sun. Day and night. In day and night, the time between the sunrise and sunset. Month. For month, the time between two new moons. Year. For this, the time the Earth takes to complete its one revolution around the Sun. Now, time measuring devices. Time measuring devices or clocks. Clocks use the concept of periodic motion to measure time. It means that it uses motions that repeat itself in equal amounts of time. There are different types of measuring devices, such as sundial. It uses the position of sun to depict time. Another example, sand clock, also known as hourglass. It uses sand to measure time. Water clock, it uses water to measure time. Quartz clocks, they have an electric circuit that works with the help of cells. They provide accurate time. Pendulum clock, it uses a pendulum to measure time. Measuring time with the help of watch seems simple, but the working of a watch is equally complex. Basically, all watches work on a universal phenomena of periodic motion. A simple pendulum is the most common example of periodic motion. By periodic motion, we mean the motion that repeats after a certain time interval. A simple pendulum is a piece of stone or a small metallic ball suspended by a thread or string from a rigid stand. This metallic ball or stone is called the pendulum's bob. The to and fro motion of pendulum is called as oscillatory motion, what we just discussed. The bob of the pendulum does move from the center, which is mean position of the pendulum, so its extreme positions on the other side. Oscillation, when the bob moves from its center, that is mean position, to its extreme ends, it is said to complete one oscillation. And time period of a pendulum is the time taken by the pendulum bob to complete one oscillation. Now, units to measure time and speed. The basic unit of time is second. It is designated by the symbol small s. The larger units of time are minute and hours. These units are connected as 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. Since the speed is distance upon time, the basic unit of speed is meter per second. Of course, it could be expressed in other units such as meter per minute or kilometer per hour. To convert between meter per second and kilometer per hour, you can divide when you have to change the larger unit into smaller unit by 3.6, and you can multiply by 3.6 when you have to change smaller unit into larger unit, that is meter per second into kilometer per hour. I would like to ask you that have you ever seen meter like device on the dashboards of car, bus, scooter or motorbike? As you can see in these pictures, these devices are called as speedometer. Generally, on the corner of these meters, kilometer per hour is written because it records speed directly into kilometer per hour. Therefore, we can say that speedometer is a device which is used in vehicles which measures the speed in kilometer per hour. There is also another meter that measures distance moved by the vehicle. This meter is called as odometer. Here is a picture of a digital odometer. So, odometer is a meter or a device which measures the distance, while speedometer is a device or meter which measures the speed. Now, what is distance time graph? In your previous classes, you must have studied about some graphs like bar graphs or line graphs. The graphs are the way to present information or data in an interesting form. It makes it easier as well because just by looking at a graph you can find a lot of data. For example, if we have any object or if there is any person whose traveling time and distance is known, like in 1 hour the person or the object covers 100 kilometers, in 2 hours it covers 200 kilometers, or maybe in 3 hours it completes 280 kilometers. Now, if you want to represent the same data graphically, it becomes distance time graph, as it is having the data about the distance and the time as well. So that is why it is called as distance time graph. In case if the distance time graph is a straight line, it indicates that object is moving with a constant speed, which is an example of uniform speed as well. Here's the data of a car moving from point A to point F through point B, C, D and E. Here's our line graph. A very good morning to all my dear students. Welcome back to your science class. Chapter number 14, Electric Current and its Effects. Electricity is the most convenient source of energy. And we all know that it is very important because it is used to run many electrical appliances like electric bulb, television, stereo, refrigerator, washing machine, computers, laptops, etc., which we use in our day-to-day life. And we cannot think our life without making use of electricity. It is produced at power stations from where it is brought to our homes through the thin wire and electric pole networks, or even by underground cables or wires. Apart from the electricity generated from the power station, there is another source of electricity, that is electric cell or battery. In order to obtain electricity from a cell or battery, we have to connect it into a circuit. So for that, let's study the electric circuit. What is electric circuit? A continuous conducting path between the two terminals of a cell or battery along with an electric current flowing in is known as electric circuit. Here you can see an image. What is this? Usually we call it battery, but it's not a battery, it's a cell. A cell is a single unit device which converts chemical energy into electric energy, while a battery usually consists of group of cells, where the positive terminal of one cell is connected to the negative terminal of the next cell. The components of electric circuit are cell, bulb, switch, wire and battery. A cell or battery is a source of electric current. A cell have a positive terminal and a negative terminal. The positive terminal of the cell is connected to the one end of the switch with a piece of copper wire. The other end of the switch is connected to the one end of the bulb holder with another piece of copper wire. The negative terminal of the cell is connected directly to the other end of the bulb holder with a copper wire. If we open the switch so that it comes in the off position, then a gap is created between the two ends of the copper wire. Due to this, one terminal of the cell gets disconnected from the bulb and therefore the current stops flowing in the circuit. Therefore, when the switch is open, the circuit breaks and no current flows through the bulb. The bulb stops glowing. When the switch is in the circuit, which means when it is closed, then the switch is said to be in an on position. When the switch is in on position, the circuit gets complete and hence a current flows in this. This current makes the bulb light up. For example, when you want to light up the bulb, you go and switch it on. When you do so, you close the circuit. It means that the circuit is completed. And when we switch off the lights, the circuit is open. It means that no current is flowing through the bulb and therefore the bulb stops glowing. Sometimes the bulb does not light up even when the switch is in the on position. It means when the circuit is closed. This can happen only if the bulb gets fused. In an electric bulb, there is a thin wire called filament, which becomes white hot and glows when electric current passes through it. When the bulb gets fused, then this filament breaks. The filament of the bulb is a part of the electric circuit. So, when the filament of the bulb breaks, the electric circuit also breaks. Under these conditions, the bulb will not light up even if the switch is in the on position or closed. Then comes switch. A switch can be connected anywhere in a circuit. When we bring the switch of a circuit in the on position, then electric current will flow instantly through the whole circuit, due to which the bulb will light up. When the switch is in off position, then no current can flow in any part of the circuit and therefore the bulb will not light up or glow. Then comes the wire in which the electricity flows and therefore the circuit gets completed. And then there is battery, which we have already discussed that battery usually consists of group of cells. Battery normally consists of several cells, thus giving it a bigger size and makes it bulky as well. A battery is mostly used for heavy duty tasks. It is used in inverters, automobiles, etc. And they are even much more costlier as compared to cell. In battery, the positive terminal of one cell is connected to the negative terminal of the next cell. To represent the electric circuits in easy way, we use symbols. The symbol of cell consists of two parallel lines, one thin and long and the other one thick and short. The long and thin line represents the positive terminal of the cell, whereas the short and thick line represents the negative terminal of the cell. Since we know that battery is group of cell, therefore symbol of battery consists of two cells joined together. In the symbol for a battery, the positive terminal of one cell is joined to the negative terminal of the other cell. Thus, the symbol for representing a battery for three cells will have three pairs of long and short parallel lines connected to one another. The symbol of electric bulb consists of a circle having a semicircle with a small loop inside it. The semicircle with a loop represents the filament of the bulb. The switch is a device which is used to make or break an electric circuit. The symbol for open switch and closed switch are as follows. A switch is also sometimes called as a key. The connecting wires are represented just by drawing a straight line. These straight lines can be horizontal as well as vertical. It is very convenient to represent various electrical components such as cell, battery, bulb, etc. by symbols. By using these symbols, electric circuits can be represented conveniently by drawing their circuit diagrams. What is circuit diagram? It is a diagram which tells us how the various components in a circuit have been connected by using the electrical symbols of the components, which is called as circuit diagram. We usually represent an electric circuit by its circuit diagram. Here you can see the image of a closed circuit and an open circuit. Heating effect of electric current. The production of heat in an electric device due to the flow of electric current is called the heating effect of electric current. You must have seen an electric heater used for cooking or an electric bulb or room heater. When these appliances are switched on after connecting to the electric supply, then their elements become red hot and release the heat. This happens due to the heating effect of electric current. The degree to which a material opposes the passage of current through itself is known as its resistance. Actually, when an electric current passes through a high resistance wire, electric energy gets converted into heat energy, and this heat energy heats up the wire. Element. All electrical heating devices consist of a coil of wire called an element. When these appliances are switched on, then their elements become red hot and release heat. There are some electric appliances such as immersion heaters, hot plates, iron, geyser, electric kettles, hair dryers, etc., which have these elements inside them. Magnetic effect of electric current. When an electric current is passed through a wire, it behaves like a magnet. This is called the magnetic effect of the electric current, which was discovered by a scientist, Hans Christian Ørsted. He discovered that the needle of a compass deflects when an electric current is passed through a wire placed near the compass. This indicates that a magnetic field is created near the wire that deflects the needle. As you can see in this picture. This picture shows the deflection in compass needle due to electric current. Now, electromagnet. We all know that every magnetic material has a magnetic field up to which the influence of its magnetism can be experienced. A magnet whose magnetic field is generated with the help of electric current is called an electromagnet, which means that electromagnet is an artificial magnet which produces a magnetic field around a conductor due to the passage of electric current through it. This magnetic field disappears when there is no current flowing through the conductor. And the difference between electromagnet and permanent magnet is that the permanent magnet maintains their magnetism for long period of time, whereas electromagnets have their own magnetic field but only as long as the current is flowing through them. Once the circuit is broken, they lose their magnetism. The applications of electromagnets. Electromagnets are used in domestic appliances such as electric bells. They are used in toys. They are used in cranes to separate magnetic materials from junk and to lift heavy objects. They are used in all kinds of telecommunication equipments. It is also used by the doctors to take out small pieces of magnetic material that have accidentally fallen in the eye. Electricity can be hazardous as well. It can cause fire due to heating or loss of life. Electric circuits must be properly insulated. If the installation breaks and the wire comes in contact with each other, they can cause a short circuit, which may give electric shocks when touched. That is why electricity should be used in a proper way to avoid any misfortune. Then comes electric bell. What is an electric bell? An electric bell consists of an electromagnet. The switch we press is used to make the circuit complete. Here you can see the image of electric bell, which is usually used in schools. The components of electric bell are a coil of wire wound over an iron piece that forms the electromagnet. Then there is an iron strip which has hammer attached to it, which is joined to the coiled wire. Then a contact screw through which it is attached to the iron strip, and a battery which connects the wired coil and the contact screw, and a switch in the middle of the circuit. Now the working of an electric bell. When the switch of the bell is on, an electric current flows through the coil of wire, which makes the iron piece attached to it act as an electromagnet. As a result, the iron piece attracts the hammer towards itself. The hammer thus hits the bell and a sound is produced. As the hammer moves towards the iron piece, it moves away from the contact screw, which breaks down the circuit. As the circuit breaks, the wire coil stops receiving any current, which makes the electromagnet lose its magnetic effect, and thus the hammer falls back to its original position. And then, as the hammer falls back, the iron strip again comes in contact with the contact screw and the circuit gets completed. This again turns the iron piece into an electromagnet, and the whole process continues until the bell is switched off. This results in the continuous ringing of the bell. So that's it for today. Study well. See you in your next class.